Well, hi everyone. We have the lesson for composition of functions, and I just want to kind of draw a illustration of it. I have like a certain domain here, X, that a point inside here can go to, let me just draw something, function called g of x. All right, so you apply the function g to x, and you get a certain output here at g of x. And then that answer could come out to something over here. We could apply a function f to that, and we would have f of that g of x. We had the x, we did something to it, and we got the g of x, and then with that answer we put that in function f and got f of g of x, and that's a composite function. And we kind of try to do it in one fell swoop and go f, and that's a little circle, f of g, f circle g. That's not fog, that's f circle g. Right here is the domain of g. And this is the domain of f. We'll talk about domains here in a little bit also. So if I have this f circle g of x, it is equal to f of x, f of g of x. And I almost prefer this to this, but they mean the same thing. So let's just create these new functions. Let's and look at a few examples. For the next few examples, let's let f of x equal 2x plus 5 and g of x equal 4x squared plus 1. All right, let's find the following. Let's find f circle g of x. All right, so I do like to do this. It lets me know that I want to put the g of x function, the g function, inside the f function. Well, the g function is 4x squared plus 1. The f function says take the input, multiply it by 2, like so, and then add 5. So let's simplify that. 2 times 4x squared, that is 8x squared. 2 times 1 is 2, plus 5. 8x squared plus 2 plus 5, that is 8x squared plus 7. So I'm getting f circle g of x equals 8x squared plus 7. Now we could check to see if is it commutative. If it is, g circle f of x would be the same thing. G of f of x. So we're going to put the f function inside g. The f function is 2x plus 5. The g function says take your input, multiply it, or square it, actually. So I'm replacing the x with 2x plus 5, square it, multiply it by 4, and add 1. So let's figure out what, I'm going to use the pattern. 2x plus 5 times 2x plus 5, that is 4x squared. 2 times 2x plus times 5 is 20x, and 5 squared is 25. And then I'm going to add 1 to that. And I'm looking at 16x squared when I distribute, plus 80x plus 100 plus 1. That 1's out here. And that is 16x squared plus 80x plus 101. All right. Now, let's say we wanted the specific value, f of g of negative 1/2. Well, f of g of x is 8x squared negative 1/2, is 8x squared plus 7. And so that would be 8 times negative 1/2 squared plus 7. Replace the x here with negative 1/2. And that's 8 times 1/4 plus 7. 8/4, that's 2, plus 7, which is 9. Okay. Now, I would offer this to you, too, that f of g of negative 1/2. Now, g of negative 1/2 is 4 times negative 1/2 squared plus 1, which is 1/4. So 4 times 1/4 plus 1, that's 4 times 1/4 is 1, plus 1 is 2. Okay, now, g of negative 1/2 is 2, so we want to find f of 2. F of 2 is, let's see, where's the f function? 2x plus 5. So 2 times 2 plus 5 is 4 plus 5, which is 9. So these answers are the same. I think we're showing here. And I just went about it. If I've already done the function, then just you can plug it in. If you have not figured out what that composite function is, this wouldn't be a bad way to go. This, I mean, right here, wouldn't be a bad way to go to get that. All right, let's deal with one more example. Okay, and this deals with domain. Let's find the domain of f of g, where f of x equals the square root of x, and g of x equals x squared plus 4. All right, well, f circled g of x is the same as f of g of x. All right, so the domain of g of x, that is x squared plus 4. G of x is x squared plus 4. We have no restrictions for what we can put in here. So the domain of g of x is all real numbers. Okay, let's just keep that in mind. Domain of g of x is all real numbers. Now, what comes out of g of x is going to be always positive, because you're going to square. If you square a negative, that's positive, and you add 4. So you're going to be able to put anything. All these numbers that you can put in f are going to be okay. We're going to be able to do the calculations, because everything that comes out of here is going to be 4 or higher. So I didn't even figure out what f of g of x is, but that's f of x squared plus 4. The f function says take the square root of, so f circle g of x is the square root of x squared plus 4. Okay, all real numbers is the domain. Okay. All right. Now, it is a little different. Let's find the domain of G circle F of X. Well, now G circle F of X, that is G of F of X, which is, let's figure out what that is first. That is G of F of X is the square root of X. I'll replace F of X with the square root of X. And the G function says square your input and add 4. The square root of X squared is X. So this is X plus 4. G circle F. Now you might think you can put any number in, but right here, the domain of F, which is your input into G, the domain of F is, let's see, we can put 0 in, right? 0 to infinity. Okay? That is also going to be, so we got to look at what we can put in first. The first things we put in G, we can only put in 0 or non-negative numbers, 0 and higher. Okay? That becomes the domain of G of F. Those are the numbers that you're going to be able to put in for the composite function, G of F of X. All right, you guys take care.